Okay, 5C. Once again, we're dealing with a quadratic-quadratic system, and the very first thing we want to do here is solve it using the graphic display calculator. So once again, I'm using the TI Inspire, but the procedure is going to be very similar to what you would do on the TI-83 or the 84. First thing I'm going to do here is enter that first equation. So I go to my, essentially what's my y equals, and I will enter 3x squared minus 3x minus 8. Press enter. I kind of like that right away. It gives me the parabola there. Then I come back to this entry line here, and it'll be 12 minus 3x minus 2x squared. Enter. Okay, now, I like this. I like what's going on here. I have got, for sure, 2 points of intersection. These two parabolas are opening in opposite directions. I know they're going to intersect twice here. Now, I've got 1 point of intersection right here. I can see that. The other one is somewhere up here. I like the fact that this happened because, again, it lets us have this little discussion here. The calculator doesn't care if the point of intersection is above the graph or below, or sorry, I should say above the screen or below the screen. It does care if it's to the left or the right. Now in this case here, that point of intersection that we're looking for here is above, okay? So the calculator is not going to have a problem for it, finding that. It will just spit out that answer. It won't give you any grief at all here. So I'm going to go down, press menu, analyze graph, intersection. And what I'll do here is I will find that one that's missing, that's above. So I'll just press enter here, come across, press enter. And then the nice thing about the Inspire is that the Inspire automatically adjusts the window setting to bring that point down a little bit lower. For the 83 or the 84, it'll just give you the answer on the bottom of the screen. It won't show you the point, but it'll tell you what it is. And up here, I can see, now I'm just going to come up here and grab that. It was the point -2, 10. I can see that when it's highlighted there. So one answer here is the point -2, 10. But I know there's another one, so I'm going to go and do that again. So analyze graph, intersection. This time I'm going to move, because I can see that the point of intersection is over here, so I'll press enter, and then I'll move my little region over there. And it found it, and in this case, again, it's easier for me to see it when I highlight it, but it's the point 2, -2. So 2 points of intersection, and I need to write the answers like this because a point is the solution to a system of equations, okay? Not saying x equals, y equals, x equals, y equals. I have to have 2 points here. Okay, now, and I know I might sound like I'm being a bit of a jerk about this, but you will lose marks if you don't write them as points. Here, now algebraically, we're going to set those two equal to each other because we are assuming, or not assuming, we know that for a couple of points on this graph, okay, remember these equations tell us how y is related to x. But because there's a point of intersection at some point, for some values for x here, the y coordinates are acting exactly the same. Okay, so for one spot here, both y coordinates are giving you 10. Both y coordinates are giving you -2 here. So there aren't many places where this occurs. And so what we do is we set them equal to each other. Now we're going to solve it. Now it's a quadratic, so I'm going to bring everything over to one side. So bring this over. Those become 5x squared. Nice thing here, it's a beautiful thing. Those linear terms go away because it's -3x and -3x. Then I'll bring the 12 over, and when I bring that over, it'll be -20 over here. So that's nice. That's really nice, okay? Because this is going to be easy to work with, especially after I divide everything here by 5. So look at x squared minus 4 is equal to 0. That is then a difference of squares. And so I'm getting my +2 and my -2 out of that right away. And actually, I should have seen that coming because I could see that the x values were -2 and +2. So I probably could have predicted that I was going to get a difference of squares out of here. Now, I've got the two values here, 2 and -2, so I'm going to try to figure out what my y coordinates would be. So and I'm lazy here, so I'm going to go to the easier equation here. So we'll start with x equals to 2. And I'll use the first one here. So 3 times x squared, well, x is 2, so this is going to be 3 times 4 is 12. Minus 3 times 2 is 6, so 12 minus 6 is 6. Minus 8 is negative 2. Okay, and that makes sense because we saw here previously 2 and negative 2. 2 gave us negative 2. Now if I go back up here and plug in the negative 2, so 3 times negative 2 squared, well that's not doing anything. The negative is going to disappear because of the square, so this is still 12. But this is going to end up becoming negative 3, or I think more like this, minus 3 times negative 2, so this is going to become negative 6, but minus negative 6. So that's all going to go to 18 minus 8 is going to give me 10. So the 2 points, just like I found with the calculator, will be negative 2, 10, and 2, negative 2. Good. Now, I was using that first equation, it's because I was being lazy, to get those points here. So now what I'm going to do to verify, okay, I'm actually going to start to be a little bit more efficient with this. I'm going to use the second equation to verify, because I used the first equation, okay, sorry, I used the first equation to get those y values. I'm just going to make sure that the second equation also works with those. So we'll take we'll take this point here, negative 2, 10, and plug that into the second equation. So is it true that 10 is equal to 12 minus 3 times negative 2 minus 2 times negative 2 squared? Is that true? Well, what do we got here? 12 minus 3 and negative 2, that's going to be positive 6. So 12 plus 6 is 18. The negative 2 squared will be positive 2. Positive 2. I'm embarrassed. Negative 2 squared will be positive 4. So negative 2 times positive 4 will be negative 8. So yeah, 18 minus 8, that's 10. Now let's try this to negative 2. So negative 2 equal to 12 minus 3 times, so in this case 2, minus 2 times 2 squared. Now let's just see, is that true? Well, this will end up being 12 minus 6, so this is 6, minus, now in this case, like up here, the square was getting rid of that negative. Here it's positive already, so this is still going to be 8, so it'll become 6 minus 8, and there it is, negative 2. So yeah, that right there, those 2 points are in fact the solution to this system.